3, 2, 1.
Good day, sir. I am Eiron Dinglasan.
Good day, sir. I'm Christian James Gallardo.
Good day, sir. I'm Melchor and Gapuz.
Good day, sir. I'm Joshua Hornales.
Good day, sir. I'm Joven.
Good day, sir. I'm Charles Adrian and Llamas.
Yan. Go.
And we are here to discuss our end semester project and pre-final examination on static and dynamics, activities and examples. The semestral journey filled with problems and solutions.
So, pasok po tayo sa unang topic, resultant, force, and components. Problem 1. Figure A shows two position vectors, the magnitude in which are A. So, ang una pong forces ay mayroon 60 meters with 30 degrees angle. Pangalawa pong force ay may 100 meters at 70 degrees angle. So, sa free body sa pag FBD po niyan is tatandaan po natin na yung dalawang arrow po is buntot arrow, tapos yung resultant po is buntot to buntot, arrow to arrow. So, para sa pag-solve po ng resultant force, gamit lang po tayo ng cosine law, which is r squared is equal to a squared plus b squared minus 2ab cosine r. So, para mawala po yung squared sa r, i-square root lang po natin. So, yun. Substitute the given. Yung a is 60, yung b is 100. Tapos yung r is 140. Kaya po naging 140 kasi yung sa 70 degrees po ng 100 meters. Sa kabila po is meron 110. Then yung sa baba po na may 30 degrees is adjacent po sa pangalawa pong arrow, kaya 110 plus 30 is 140. So, ang makukuha po natin resultant ay 150.97 or 151 meters. Sa pag-solve naman po ng angle ng resultant, gamit naman po tayo ng sine law. So, 151 over sine 140 is equals to 100 over sine theta. So, cross multiply, sine theta times 151 is equal to 100 sine 140. So, sa pag-solve po, using our calcu, shift sine 100 times sine 140 divided by 151. Makuha po nating sagot is 25.2. So, para makuha po natin yung pinaka-angle po ng resultant from x-axis, 25.2 plus 30 degrees, magiging sagot po is 55.2 degrees. So, pasok tayo sa problem 2. Determine the magnitude and direction of the resultant of the force system shown. So, dito, force P na may 40 kN at may 20 degrees angle. Force Q na may 60 kN at 45 degrees angle. Pag body diagram natin, ganito ang kanyang kalalabasan. So, sa pag-solve ng magnitude ng resultant, use cosine law, which is r squared is equal to a squared plus b squared minus 2ab cosine r. Sub nyo na lang yung mga value. Ang makuha nating r is 56.32 kN. Sa pag-solve naman ng direction ng resultant, use sine law. R over sine r is equal to 60 kN over sine theta. Sub yung value ng r, then cross multiply. Ang magiging sine theta is equal to 60 sine 65 over 56.32. Using our calcu, shift sine, ang magiging sagot is 74.91 or 75 degree. Para makuha natin yung direction talaga ng resultant from x-axis, i-add natin ang nakuha nating sagot sa 20. So, 75 plus 20 is equal to 95 degrees. Problem 3. force of 200 kN is directed as shown in the figure. So, meron po tayong force na 200 kN at may 30 degrees angle. Solve po natin ang force Y at ang force of X nito. Para makuha po natin ito, ang mga formula po na kailangan natin gamitin is Fx is equal to F cosine theta, Fy is equal to F sin theta, tangent theta is equal to Fy over F of X. Tapos, para masolve ang F, square root of F of X squared plus F of Y squared. So, using our example, ang force natin ay may 200 kN. Sa pag-solve ng F of X, 200 multiply to cosine 30. Ang F of X natin is 173.21. So, sa F of Y naman, F sin theta, 200 times sin 30. Ang Fy natin is 100 kN. So, pasok po tayo sa problem 4. Determine the X and Y component of each of the following forces shown on the figure. So, umpisahan po natin sa force P na may 200 kN at may 60 degrees angle. So, F of Y is equal to sin theta times F. So, sub po, sin 60 times 200. Ang F of Y po natin is 173.205 kN. Then, F of X is equals to cosine theta F. Cosine 60 times 200. Ang F of X po ng force P is 100 kN. So, pasok naman po tayo sa force T na may 722 kN. Para makuha po natin ang angle niya is tangent theta F of X over F of Y. Ang F of X is 2, ang F of Y is 3. So, shift tangent to 3 over 2. Ang makukuha po natin is 56.31. Yun po yung magiging angle ng force T. So, F of Y sin theta times T. So, sin 56.31 times 722 kN. Ang sagot is 600.74 kN. Ang X component naman, cosine theta times T. Bale, ang magiging sagot is 400.49 kN. Last, ang force F na may 498 kN at may F of X na 2 at F of Y na 1. Para makuha natin yung angle ng force F is kaya ng ginawa natin kanina sa force T, shift tangent 1 over 2. Ang magiging sagot is 26.25. Bali yun yung magiging angle natin sa force F. So, F of Y is equal to sin theta F. Sagot is 222.21. Then sa F of X ng F is cosine theta F. Ang magiging sagot is 445.67. So, pasok po tayo sa problem 5. The triangular block shown in this figure is subjected to the loads P is equal to 16,000 kN and F is equal to 800 kN. If AB is equal to 8 meters and BC is equal to 6 meters, resolve each load into components normal and tangential to AC. So, una po nating isolve yung tangent ng force po ng P, ng P loads. Bali, dito sa free body diagram natin, is inusog lang po muna natin yung force P saka into sa resultant natin. Then, kinonect po natin yung isa pang arrow sa resultant ng AC. So, kung magagawa po tayo ng isa pang maliit na triangle dito, which is equal naman po sa triangle ABC, is magiging equal po siya sa sa triangle na nabuo po ng force P. So, since yung BC is 6 meters, magiging sukat niya po is 3. Then yung 8 is 4. Para makuha naman po ang C, gamit po tayo ng Pythagorean theorem na a squared plus b squared is equal to c squared. Sub po natin yung mga values. Makukuha natin C is equal to 5. So, para makuha natin yung normal force ng P is gamit lang po tayo ng sin theta times P. So, sin 45 times 160 ay 1,600 is 1,280 kilonewton. Then, yung tangential force P, cosine theta, multiply to 1,600, magiging 35 times 1,600. Ang sagot is 960 kilonewton. Next, solve natin is component loads ng F. So, gaya po ng sa kanina po, bali inangat lang po namin yung arrow po na yung force F para tumama po sa resultant natin na AC. So, sa paggawa po ng normal force of F, sin theta times F, which is 800. So, 45 times 800. Magiging sagot is 640 kilonewton. Then, yung tangential force ng F naman, cosine theta, is equal to, F is equal to cosine theta times F. So, 800 times 35, magiging sagot is 480 kilonewton. Then, pasok po tayo sa problem 6. Find the resultant of the concurrent force system shown in this figure. So, meron po tayong 4 na forces. So, kailangan po nating hanapin kung nasaan po yung resultant, kaya yung angle po ng resultant. So, para makuha po natin yung position ng resultant, gagamit po tayo ng formula na summation forces is equal to R. So, sa una is summation forces of X is equal to Rx. So, meron po tayo ditong dalawang force F of X. Una is yung sa 200 sa may force na 200 kilonewton at sa may force na 300 kilonewton. So, magiging 200 cosine 30. Since positive siya, ay yung arrow niya is nasa papuntang pakanan, positive ang sign. Then sa 300 kilonewton, cosine 60. Since ang f of x is pakaliwa, magiging negative. So minus, bali magiging sagot is negative 306.8 kilonewton. Then sa f of y naman, summation of f of y is equal to ry. Gawin din po natin yung ginawa natin kanina. Pagsasamahin po natin yung mga f of y ng mga loads. So sa 200 kilonewton sin 30, since pataas siya, ang sign niya is positive. Sa 300 kilonewton times sin 60, since pataas din siya, positive ang sign. Sa 500 kilonewton, since nasa y-axis na siya, is 500 na lang yung ilalagay natin. Then is yung 100 sin 45. Since pababa ang f of y, siya ay negative. So, solve. Ang magiging sagot is negative 210.903 kN. Kung mapapansin po natin sa R of X natin at sa RY, parehas po siyang negative yung sagot. So, ibig sabihin po no, na ang resultant natin is magiging nasa quadrant 3 since parehas negative ang forces na nakuha natin. So, para makuha naman yung angle length ng R natin, R is equal to square root of Rx squared plus Ry squared. So, sub natin. Ang magiging sagot is 371.703. Balihin yung force ng R natin. Sa angle naman is tangent theta is equal to Ry over Rx. So, using our calcu, shift tangent, 210.903 divide 306.8. Magiging angle po ng R natin is 34.57. Problem 7. The resultant of the concurrent forces is 300 kN pointing up doing the y-axis. Compute the value of F and theta required giving this resultant. So, meron po tayo ditong apat na forces. Una yung Ry na nasa mismong y-axis na meron 300 kN. Sunod is 500 kN na nasa mismong x-axis naman. At ang isa na nasa quadrant 4 na merong force na 240 kN at may angle na 30 degrees. So, sa pagkuha natin ng F is gagamit tayo ng summation forces. So, since yung Rx natin is nasa mismong x-axis, ang magiging value niya is 0. Ang Ry naman is 300 kN. So, 0 is equal to F cosine theta minus 500 kN. Negative kasi yung 500 is nasa negative x-axis. Plus 240 kN cosine 30. So, solve. Makuha natin na value is 292.2. Value pa lang po yan ng F cosine theta. Then, Ry is equal to Fy. So, yung Ry natin is 300 kN. So, F sin theta minus sin 30 degrees times 240. Ang magiging F sin theta natin is equal to 420. So, using our formula from tangent theta is equal to F of y over F of x. Yung value po ng F sin theta at ng F cosine theta is equal na sa 420 over 292.2. Using our calcu, shift tangent, ang makuha nating value ng theta is 55.17. So, i-sub lang natin yung value ng theta sa F sin theta. So, F sin 55.17 is equal to 420. Ang magiging F natin ay 511.66 kN. So, ang force F is 511.66 at ang angle niya is 55.17. So, example 1 ng resultant force and components natin. Two horses on opposite banks of a canal pull a barge moving parallel to the banks by means of two horizontal ropes. The tension in these ropes are 200 kN and 240 kN, while the angle between them is 60 degrees. Find the resultant pull on the barge and the angle between each of the ropes and the sides of the canal. So, magkakaroon po tayo ng isang resultant po sa dalawang loads. Pero magkakaiba po sila ng angle. So papangalanan na lang po natin yung angle ng 200 kN na theta. At yung sa 240 is alpha. Since ang kabuuang angle niya is 60 degrees. So magkakaroon to tayo ng theta plus alpha is equal to 60 degrees. Transposition lang natin. Alpha is equal to 60 degrees minus theta. Bali yun yung magiging equation 1 natin. So, pasok naman tayo sa summation forces of y is equal to ry. Since yung r natin is nasa x-axis, mawawalan na siya ng ry. Bali, ang magiging value niya is 0. So, 0 is equal to 200 sin theta minus 240 sin alpha. Bale, ito na yung magiging equation 2 natin. So, yung isab natin yung value ng sin alpha, which is 60 degrees minus theta. So, 200 sin theta minus 240 times sin 60 cosine theta minus cosine 60 sin theta. Combine like terms. 200 sin theta minus 207.85 cosine theta plus 120 sin theta. So, pwede natin na mapag-iwalay yung dalawang sin. Bali, magiging sin theta times the sum of 200 plus 120 minus 207.85 cosine theta. So, 0 is equal to 320 sin theta minus 207.85 cosine theta. So, using
Saan ako, pre?
so transposition, magiging 320 is equal to 207.85. So, di-divide po natin siya sa 320 cosine theta para matanggal po yung cosine sa kabila, matanggal naman po yung value sa tabi ng sin theta. So, magiging sin theta over cosine theta is equal to 207.85 over 320. Mapapansin naman po natin na yung sin over cosine is equal to tangent. So, tangent theta is equal to 207.85 is equal to 320. So, shift tangent, ang magiging sagot is 33 degrees. So, may value na tayo ng theta. So, balik po tayo sa equation 1 na alpha is equal to 60 degrees minus theta. Sub na natin yung value ng theta into 30 degrees. 60 minus 33 is equal to 27. So, ang value ng ating alpha is 27 degrees. So, pasok naman po tayo sa summation forces of x is equal to rx. So, sa load po ng 200, so cosine theta, which is 33 degrees. Bali, kaya siya negative kasi yung motion ng forces natin is papunta sa negative x axis. Ganon din sa isang horse natin na may 240 forces, negative siya. So, solve. Ang Rx natin is equal to negative 381.58 kN. So, para makuha na natin yung R, equals na natin siya sa square root of Rx squared plus Ry squared. Since wala naman value yung Ry natin is makakancel na siya. So, ang equation na lang natin is square root of 381.58 squared. So, ang sagot is makakancel yung squared, magiging 381.58 kN na lang. So, ang value ng ating R is 381.58. So, yun po. Let's proceed to problem 8. In figure, assuming clockwise moments as positive, compute the moment of force F equals 450 kN and of force P equals 361 kN about points A, B, C, and D. So, this is the figure. Kung makikita po natin, assume po natin na every distance po is 1 meter or 1 unit. So, next po for solution. So, ang una po natin gagawin is kukunin po natin yung X and Y component ng force. So, para sa ating unang force, f of x equals f cosine theta. So, makukuha natin is 450 times 4 over 5. So, yung unang f of x ng ating unang force is 360 kN. And next naman po ang kunin is yung f of y. So, f of y equals f sine theta. So, 450 times 3 over 5. And makukuha po natin f of y is 270 kN. So, nakuha na po natin yung x and y component ng unang force. Susunod naman po natin kunin ay yung pangalawang force. So, sa pangalawang force, ang makukuha nating f of x. So, using the formula, P cosine theta. So, 361 times 2 over the square root of 13. So, makukuha nating f of x sa pangalawang force is 261 kN. Next naman po kukunin natin ang f of y ng pangalawang force. So, using the formula P cosine theta. Again, so, 361 times 3 over square root of 13. So, ang makukuha po natin is 300 kN. So, ang next naman po natin gagawin after makuha yung dalawang x and y component ng dalawang force, magmo-moment po tayo. So, moment of force F, pag clockwise po is positive. So, pag counterclockwise naman po is negative. So, moment of force F equals summation of moment. So, moment A equals negative 360 dahil counterclockwise times 3, which is yung distance niya from the A. And then minus 270 again dahil nga counterclockwise times 1, which is yung distance niya from the A ng isang force. So, makukuha natin sa moment A is negative 135 negative 1,350 kN meter. Ang next naman natin is magmo-moment tayo sa B. So, moment B equals negative 360 times 3, which is yung distance niya from the B, plus 270 times 5 dahil clockwise. So, ang moment natin sa B is 2,160 kN meter. Next naman natin kukunin is yung moment sa C. So, moment C equals 360 times 0. Dahil kung makikita naman natin, diretso lang siya sa C. So, wala siyang, so makakancel na yon. So, plus 270 times 5. So, yung moment sa C natin is 1,350 kN meter. So, ang next naman natin is moment sa D. So, moment D equals 360 dahil nga positive or dahil counterclockwise. So, 360 times 3, which is yung distance niya from the D. And then, minus 270 minus dahil counterclockwise times 1. So, yung moment natin sa D sa unang force is 850 kN meter. So, next naman na So, next naman ay gagamitin natin yung isa pang force, which is yung force P. So, ganun din, clockwise is positive, counterclockwise is negative. So, summation of moment. So, moment of A equals negative 200. Dahil kung makikita natin ulit sa figure is counterclockwise yung ikot niya, times 3 which is yung distance, and then plus 200 clockwise, dahil clockwise, and then times 2. So, makukuha natin dito is sa moment A is 0 kN meter. Next naman is moment B. Moment B equals 360 because it is clockwise times 3 which is yung distance minus 300 dahil counterclockwise times 3, and makukuha natin yung sa moment ng B is equal to negative 300 kN meter. Next naman is sa moment C ng ating force P. So, moment C equals 200 times 3 plus 300 times 4. So, dito, makukuha natin yung moment sa C equals negative 1,300 kN meter. Next naman is ganun ulit ang ating process. So, kailangan natin ma-master to kaya natin pinauulit-ulit. So, moment B equals 200 times 3 plus 300 times 2 equals, yung moment din natin is 1,200 kN meter. So, yun po, ganun lang po kasimple. So, next problem, problem 9. 1. Compute the horizontal component of the resultant force. 2. Compute the vertical component of the resultant force. Number 3. Compute the location of the resultant force from point A. So, this is po the figure. Meron po tayong dalawang forces na may 100 kN and 200 kN respectively. And ang unang force po natin ay may 50 degrees, ang isa naman ay may 35 degrees. So, each line po ay may distance na 1 meter. So, next po, for solution, ang una po natin kukunin is yung x component and y component ng each forces. So, for force 1 po muna, yung may 100 kN na force, f of x equals 100 sin 50. So, yung f of x niya po is equal to 76.60. And next po, kukunin na po natin is yung f of y. So, f of y equals 100 cosine 50 equals 64.28. So, meron na po tayong f of x and f of y sa una nating force. Kunin naman po natin yung pangalawang force, which is yung 200 kN na force. So, f of x equals 200 cosine 35 equals 163.83. Yun po yung kanyang f of x. Anong f of y naman niya po is 200 times sine 35, which is equal to 144.72. So, nakuha na po natin yung f of x and f of y ng dalawang forces. Ang next naman po natin na kukunin ay ang kanyang, sabi nga po sa number 1, kunin po natin ang kanyang horizontal component and yung number 2, vertical component. So, una po, horizontal component. So, RH equals positive ang right side and negative pag pupunta sa left side. In summation of forces horizontal. So, RH equals negative 100 sin 50. Negative dahil kung makikita po natin sa figure, yung force po is papunta sa left side or sa negative. And then, yung isa namang force is plus 200 cosine 35. Positive dahil kung makikita po natin ulit sa figure, siya po ay papunta sa right side. So, kung equate po natin, ang RH po natin is 87.23 kN. So, yun po yung ating RH. Next naman po is yung vertical component of resultant force. So, para po makuha yun, summation po ng ating force vertical. So, RV equals positive pag pataas and negative pag pababa. So, RV equals 100 cosine 50. And then,
plus po yun, 200 sine 35. So kapag in-equate po natin yon, RV equals, ang makuha po natin na R vertical is 179 kN. So meron na po tayong RH and RV. Ngayon naman po, yung number 3 na pinapakuha sa atin is yung location of the resultant force from point A. So para po makuha natin yon, kailangan po muna natin makuha yung kanyang resultant. So para po makuha yon, ang formula po natin doon is R equals square root of Rx squared plus Ry squared, or R equals square root of R horizontal squared plus R vertical squared. So kung isa-substitute lang po natin yon, makukuha po natin resultant is 199.12 kN. Yun po, meron na po tayong resultant. Pero di pa rin po tapos dahil ang kinukuha po natin dito is location po ng resultant force from point A. So, gamit po yung formula na R times D equals the summation of moment A. And clockwise po pag positive and negative po pag counterclockwise. So, substitute po natin 199.2, yun po yung ating resultant, times D equals, so gamit po yung nakuha nating f of x and f of y, dito po natin gagamitin yon. So equals negative po dahil counterclockwise yung 76.60 times 4, which is yung distance niya from the A, and then plus 114.72 positive dahil clockwise times 5 na distance, and yun na yung ating equation. So para makuha natin yung distance, kailangan lang natin i-manipulate yung equation. So using manipulation, D equals 267.2 over 199.12. So ang makukuha po nating distance ng ating resultants from A is 1.34 meter. So ganun po. So next, for our next problem, example 2. Two forces acting at A and B shown in figure. It required to determine the location of each resultant from O. So ito po yung ating figure. Kung mapapansin po natin, inuna po natin kuhanin yung mga location po na ating magagamit and dimension para mapabilis ang ating pag-solve. So for solution, una natin kukunin ang resultant in horizontal. So RH equals positive pag right side and negative naman pag papunta sa left side. And kukunin natin yung summation of horizontal force. So for RH equals negative 20 dahil yung force is pupunta sa left side. And then minus 30, which is yung isang horizontal ay pupunta rin sa isang left side. So negative 20 minus 30 is negative 50 kN. So yun po yung ating RH. Next naman is kukunin natin yung RV or yung vertical resultant. So using the formula, RV equals the summation of force B, positive if papunta sa taas and negative pag downward. So RV equals 10 positive dahil papunta sa taas and negative 4 dahil papunta sa baba. So RV equals 10 minus 4. So makakuha nating RV is 6 kN. And then para makuha yung resultant, using the formula, R equals the square root of RV squared plus R horizontal squared. So substitute lang natin yung value na nakuha natin. R equals square root of 50 squared plus 6 squared. So pag kinalculate natin, R equals 50.36 kN. And then para makuha naman natin yung distance niya from 0.0, kailangan natin gamitin yung formula na R times D equals summation moment O. So, substitute lang natin yung nakuha nating resultant. So, negative 50.36 times D equals negative 20 dahil yung negative 20 is papunta sa left side. And then, times 6 dahil yung kanyang distance is 6 meters from the point O. And then, minus 10 times 4 minus 30 times 2 plus 4 times 8. So, para makuha natin yung distance, kailangan natin i-manipulate yung equation. So, D equals negative 20 times 6 minus 10 times 4 minus 30 times 2 plus 4 times 8 all over negative 50.36. So, kapag kinalculate natin ito, makuha natin distance is 3.73 meters. So, yung distance ng resultant from point O. So, let's proceed to our next problem. Problem 10. A parallel force system acts on the level. Determine the magnitude and position of the resultant from O. So, as you can see in the table, meron tayong 30 kN, 60 kN, 20 kN, and 40 kN. And naka-indicate na rin yung dimension ng bawat forces na nag-act sa isang horizontal. So, for our solution, for our problem 10, ang una natin kukunin is yung resultant. So, using the formula, R equals the summation of force vertical. Dahil lahat naman nating force is vertical. So, positive pag pataas and negative pag pababa. So, R equals negative 30 dahil pababa yung negative 30. And then minus 60 dahil pababa ulit. Plus 20 positive dahil pataas, and negative 40. So, ang makukuha natin resultant is negative 110 kN. So, para naman makuha natin yung distance niya, using the formula, R times D equals the summation moment O. Clockwise pag positive and counterclockwise pag negative. So, yung nakuha natin resultant, 110 times D equals 30 positive dahil clockwise times 2 which is yung distance niya from the distance niya, and then plus 60 dahil clockwise, and then times 5 yun yung distance, and then minus 20 which is negative dahil nga counterclockwise, times 7, and then plus 40 times 11. So, yun yung ating equation na nabuo based sa figure na ating ginawa. And then, tulad ng mga previous problem natin, kailangan ulit natin i-manipulate yung equation para makuha natin yung D. So, D equals 30 times 2 plus 60 times 5 minus 20 times 7 plus 40 times 11 all over 110. So, yung distance na makukuha natin is 6 meter. Yun yung distance ng resultant from point O. So, problem 11. Find the value of P and F so that the four forces produce an upward resultant of 300 kN acting at 4 meter from the left end of the bar. So, this is our figure. Kung makikita nyo, meron tayong 100 kN downward. And then may P tayo, force P, upward, na ating kukunin, and F naman pag downward. So, sabi dito, may resultant tayo na 300 kN. And then may isa pa tayong force, which is 200 kN upward. So, for our solution, ang una nating gagawin is bumuo ng dalawang equation. So, para makabuo tayo ng unang equation, base sa pag-analyze, ang kailangan natin gamitin na formula is R equals the summation of F vertical. So, positive ulit pag pataas and negative pag pababa. So, given yung R, which is 300, substitute lang natin doon sa formula. So, 300 equals negative 100, yung una nating force, pababa, kaya negative, plus P, pataas yung P, kaya positive, minus F, pababa yung force F natin, kaya negative, and then positive 200 dahil pataas yung isang force. So, ililipat lang natin yung lahat ng may value sa left side and yung variable sa right side para mas simplify. So, 300 plus 100 minus 200 is 200. So, 200 equals P minus F or P minus F equals 200. So, yun yung ating unang equation na nakuha. Sunod naman natin gagawin is kukuha naman tayo ng pangalawang equation. So, using the formula R times D equals the summation of moment A. So substitute lang ulit natin lahat ng nakuha nating lahat ng value na meron tayo. So, una, yung resultant ng 300. So, negative 300 times the distance, which is yung 4, equals negative 2p plus 5f minus 200 times 7. So, simplify. Negative 1,200 equals negative 2p plus 5f minus 1,400. So, negative 1,200 plus 1,400 equals negative 2p plus 5f. So, simplify lang natin yon. So, makakuha natin is 200 equals negative 2p plus 5f. So, yun yung ating equation 2. Ngayon, para may makuha tayong value, ipapasok natin yung isang equation sa isa pang equation. So, using the formula na equation 2, gagamitin natin siya para ipasok yung isa pang formula na P. So, yung equation 2 natin, 200 equals negative 2P plus 5F. And then, 200 equals negative 2. Substitute natin yung value ng P, which is yung 200 plus F plus 5F. Sorry. And then, dahil may pares na tayong variable, pwede natin i-simplify yung equation. So, 200 equals negative 400 minus 2F plus 5F. So, minultiply lang natin yung 2 sa dalawang value. And then, simplify pa ulit, lipat natin yung negative 400 sa left side. And then, simplify yung nasa right side. So, ang mangyayari, 200 plus 400 equals 3F. And then, dahil yung F nga yung kinukuha natin, kailangan ulit natin manipulate yung equation. So, F equals 200 plus 400 all over 3. And then, ang makukuha nating F is 200 kN. So, ayun. So, next problem na tayo. And this is example 1. Locate the amount and position of the resultant of the load acting on the pink truss shown in figure. So, this is our figure po. Makita po natin, meron tayong force downward na 200 kN, 300 kN, 400, 300, 200, and 2,000 kN. And then may dimension sa baba na take the 10 meters. So, for our solution, gagamitin ulit natin is para makuha yung resultant is R equals the summation of F vertical. Dahil vertical lang naman din lahat ng ating forces. So, positive ulit pag pataas and negative pag pababa. So, for our solution, R equals negative 200 dahil pababa, minus 300, minus 400, minus 300, minus 200, and then minus 2,000. Kung mapapansin natin, puro minus ang operation dahil nga puro pababa naman ang ating forces. So, makukuha natin resultant is equal to negative 3,400 kN. And then, para naman makuha natin yung distance, gagamit tayo ng formula na R times D equals to summation of moment A. Clockwise is positive and counterclockwise pag negative. So, substitute lang natin yung resultant na nakuha natin. So, positive 3,400 times D equals 1,400 times 15 dahil nasa gitna yung ating resultant plus 2,000 times 10. So, para makuha yung distance, i-manipulate natin ulit or i-derivation yung ating equation. So, D equals 1,400 times 15 plus 2,000 times 10 all over 3,400. So, kapag kinalculate natin ito, ang lalabas ay D equals 12.06 meters. So, yun po yung ating distance. So, for our next one, example 2. So, figure lang ang meron tayo pero kukunin natin ang resultant and distance para ma-practice pa natin ng maayos ang pagkuha nito. So, kung makikita natin sa figure, meron tayong 300 kN per meter and sa right side naman is 200 kN per meter. Sa 300 kN per meter, meron doon nakalagay siya sa 2 meters. And yung 200 kN per meter naman is nakalagay sa 3 meters. And then may 2,000 kN na isa pang force. So, for our solution, gagamit tayo ng formula na R equals summation of force vertical dahil vertical lang din naman lahat ng ating forces. So, positive pataas and negative pag pababa. So, R equals negative 300 kN per meter times 2 meter dahil doon nga siya nakalagay sa 2 meters. And then, minus 2,000 kN and then minus 200 kN per meter yon, and then nag-times 3 dahil doon nga siya nakalagay sa 3 meters na length. So, kapag kinalculate natin, makukuha natin is R equals negative 3,200 kN. So, meron na tayong resultant. So, kukunin naman natin yung distance ng resultant from the moment A. So, gamit yung formula na R times D equals to summation of moment A. Clockwise pag positive and counterclockwise if negative. So, resultant 3,200 times D equals 300 times 2 times 1 plus 2,000 times 2. Yun yung distance nila sa point A plus 200 times 3 and then yung distance niya is 3.5. So, yun yung ating makukuha equation kapag kapag ginamit natin yung formula na ito. So, para makuha yung D, i-derive lang ulit natin. So, D equals 300 times 2 times 1 plus 2,000 times 2 plus 200 times 3 times 3.5 all over 3,200. So, kapag kinalculate natin nito, ang lalabas na ating distance is 2.09 meter. So, for our next example, example 4, So this is the figure. So meron tayong forces na 10 kN, 20 kN, 30 kN, and 40 kN. Then may mga point tayo. Point A, point B, point C, point D, and point E. So, ang gagawin natin is kukunin natin yung resultant and yung mga moment sa bawat point. So, for our resultant, using the formula R equals the summation of force vertical, dahil vertical lang naman yung ating mga forces. So, R equals negative 10 dahil pababa yung negative 10 plus 20 plus 30 and then minus 40 which is pababa yung 40 kN na force. So, ang makukuha nating resultant is 0. So, yun yung ating resultant. R equals 0. And then using the formula R times D equals the summation of moment A. Kung mapapansin natin, yung resultant natin is 0. So, substitute lang natin to sa formula. So, 0 times D equals summation of moment A. So, dahil 0 nga yung resultant natin, magiging 0 yung sa left side. So, ang makukuha natin is summation of moment A is equal to 0. And then, para makuha naman natin lahat ng moment sa bawat point, isa-isahin natin ito. Using the formula, summation moment of a point equals the summation moment. So, for moment A, summation moment A equals summation moment. Clockwise if positive. And negative naman kapag counterclockwise. So, summation moment A equals 10 times 2 dahil 2 yung distance niya sa A, and then minus 20 counterclockwise times 5 which is yung distance niya from the A, minus 30 dahil counterclockwise, and then 6 times 6 which is yung distance niya from the A, and then plus 40 times 8. So, yung summation moment natin sa A is 60 kN meter. Ang next naman natin kukunin is yung moment sa B. So, summation moment B equals summation moment clockwise positive and negative kapag counterclockwise. So, summation moment B equals negative 20 times 3, negative dahil counterclockwise, and then times 3 dahil yung distance niya from the B. And then, sa next force naman natin is negative 30 dahil counterclockwise, and then times 4 dahil yun yung distance niya from the D. And next force naman is positive 40 dahil clockwise yung ikot niya, and then times 6 which is yung kanyang distance from the B. So, kung mapapansin natin, nawala dito yung force na 10 dahil nga yung force na 10 is nandoon sa mismong point na yon. So, ibig sabihin, wala siyang distance or 0 yung distance niya, kaya makakancel lang siya. So, kapag in-equate natin itong equation na nagawa natin, kung makuha natin moment sa B is 60 kN meter. Next one naman is moment sa C. So, para makuha yung moment sa C, summation moment C equals summation moment. Clockwise, pag positive, and counterclockwise, gagawin natin negative. So, summation moment C equals negative 10 downward, kaya I mean counterclockwise yung 10, and then kaya negative times 3 minus 30 times 1 counterclockwise ulit, kaya naging negative, and then positive 40 times 3. So, yung makuha nating moment dito sa C is 60 kN meter. Next one naman is summation moment D. So, para makuha natin sa moment D, summation moment D equals summation moment. So, clockwise again, gagawin natin positive, and then negative naman kapag counterclockwise. So, summation moment D equals negative 10 dahil counterclockwise, and then times 4, which is yung distance niya from the D, and then yung plus 20 force times 1, which is yung distance niya from the D, and then positive 40 again dahil clockwise times 2, which is yung distance niya from the D. So kapag in-equate natin, ang makuha natin value is 60 kN meter, and din yung ating summation moment P. For the last one naman, kung kunin natin is moment E. So summation moment E equals summation moment, positive kapag clockwise and negative kapag counterclockwise. So summation moment E equals negative 10 dahil counterclockwise again, and then 6 yung distance niya, kaya multiplied by 6, plus 20 times 3, positive dahil clockwise, and then plus 30 clockwise ulit, times 2, which is yung distance niya from the E. So kung makakuha nating moment E is 60 kN meter. So yun yung mga value na nakuha natin using the formula. So kapag nagganito tayo, kailangan nating maging careful sa mga sa sign, dahil mamamali ang makukuha nating value kapag hindi natin tinignan ng maayos yung figure na given.
So to continue our discussion, we have another example number 5, which is all about couples. So let's learn more about couples. So a couple is defined as two parallel forces with the same magnitude but opposite in direction, separated by a perpendicular distance. So sinasabi lang po dito na we have two parallel forces na parehas po ng magnitude but that are acting on opposite directions. Pwede pong isang pataas, pwede pong isang pababa. So example number 5. The cantilever truss shown in figure carries vertical load of 2,400 kN. The truss is supported by bearings A, B, and A, which exerts the forces AV, AH, and BH. The four forces shown constitute two couples, which most have opposite moment effects to prevent moment of the truss. Determine the magnitude of the supporting forces. So makita po natin dito na ang ating letter A is a fixed, has a fixed support. So meron pong dalawang forces na mag-act dito, which is on vertical and the other one is on horizontal. While on the B, which is has a support of bearing. So kapag bearing po, meron lang po siyang isang forces na nag-act, which is ito po. Dito sa figure po natin is pa horizontal. So for the solution of example number 5, we are looking for three forces, which is BH, AH, and AV. So to solve, the summation of moment at A will be equal to 0. Tapos lahat po ng pa-clockwise is positive at lahat naman po ng pa-counterclockwise is negative. So magmo-moment po tayo sa A para makuha po natin si BH. So as you can see, yung BH po will move clockwise, so magiging positive po siya, and it has a moment arm of 4. So BH multiplied by 4 minus 2,400 multiplied by 6. Bakit po naging minus? Kasi po yung 2,400 is pa-counterclockwise naman po siya, papunta po dun sa A. And then 6 po, minultiply po natin sa 6 because yung moment arm niya po ay 6. And also equal to 0. And then isolating the BH on the left side, we need to transpose the 2,400 multiplied by 6 on the right side and then dividing both sides by 4. So we can obtain the BH, and 2,400 multiplied by 6 divided by 4 is 3,600. So our BH is 3,600 kilonewton. So now that we have the BH, we can now solve for the AH. So, para naman po makuha po natin si AH, horizontal, pwede po tayo mag-moment sa B. Para si AV po natin is wala pa rin po kasi wala po siyang moment arm. So, parehas pa rin po, summation of moment at B is equals to 0, considering that lahat ng pa-clockwise po is positive and lahat ng po ng pa-counterclockwise is negative. So, AH which is moving clockwise, so positive po, multiplied by the moment arm 4 minus 2,400 kasi po minus dahil pa counterclockwise po papunta sa B, and multiplied by 6 kasi 6 po ang kanyang moment arm is equals to 0. So isolating, katulad din po, isolating AH on the left side, transpose negative 200, 2,400 multiplied by 6 on the right side, and then dividing both sides by 4, so we can obtain the AH. So AH is equals to 3,600 kilonewton. Now that we have AH, AV na lang po yung hinahanap natin. So to find the AV, we can moment here at the 2,400 kilonewton, or we can say that this is the point C. So the summation of moment at C is equals to 0, considering that clockwise nga po is positive and then counterclockwise is negative. And then BH, 3,600 multiplied by 4, its moment arm, minus AV dahil ang movement po nito ay pa-counterclockwise papunta dun kay C, then multiplied by 6, ito po yung kanyang moment arm is equals to 0, and then katulad po kanina, isolating, lipat po natin sa kabila yung AV, and then then divide both sides by 6 to obtain the AV. So AV is equals to 2,400 kilonewton. So as you can see po, yung ating BH ay the same as the AH kasi parehas po silang horizontal, and then yung AV naman po natin, which is 2,400, is the same po dito sa force na nasa may point C po natin, which is 2,400. Yun po yung sinasabi po sa couples. So for our next topic, which is equilibrium of concurrent forces. So problem number 12. The cable and boom shown in the figure below support a load of 600 kilonewton. Determine the tensile force in the cable and the compressive force in the boom. So to solve, kailangan po natin dito ng kasi nawawala po sa atin dito ang T at saka yung C. So kailangan po natin gumawa po ng dalawang equation. So para magawa po natin yon, gamitin po natin mag-component po tayo. So the summation of forces at H is equals to 0, considering that all forces that move to the right is positive and the forces that move to the left is negative. So, ayan. So, dito po, makikita po natin, negative cosine 30t. Naging negative cosine 30 kasi nga po, yung TH po natin is, o yung T horizontal po natin is papunta po siya sa left side. And then cosine 30 kasi po naka-adjacent po siya dun sa ating angle na 30. So cosine po yung ginamit. Plus cosine 45C. Dito po sa C natin, papansin po natin na papunta po siya sa kanan yung horizontal, so cosine nag-positive po siya, and then cosine 45 kasi naka-adjacent din po siya is equals to 0, and then cosine 45C is equals to cosine 30t, and then isolate po natin si C sa other side. So magiging equation po natin sa C is equals to cosine 30t over cosine 45 degrees. So, meron na po tayong equation number 1. Ngayon, para naman po makuha natin equation number 2, hanapin naman po natin yung mga summation ng forces vertical. So, lahat po ng pataas is positive, lahat po ng pababa is negative. So, sin 30, kasi po, pataas po yung ating vertical forces dito sa T. So, sin 30 kasi din po, naging sin po siya kasi, opposite po sa angle na 30 degrees. And then, ganoon din po, positive din po dito sa may ating C kasi pataas po. And then, opposite din po ng 45 yung ating vertical force. Minus the 600 kasi di ba meron po tayong load na 600 which is pababa. So, naging minus siya is equals to 0. So, sin 30t plus sin 45c is equals to 600. So, yun po yung ating magiging equation number 2. So, yun naman po, para makuha po natin yun, gamitin po natin yung both equation. So, gamitin po natin yung equation number 2, and then, isubstitute po natin yung value ng c na nakuha natin sa equation number 1, which is cosine 30t over cosine 45. So, sine 30t plus sine 45 degrees multiplied by cosine 30t over cosine 45 degrees is equals to 600. And then, solve for t. So, our t will be 439.23 kilonewton. And now that we have the t, ang gawin po natin is, substitute naman po natin siya, gamitin natin yung equation number 1 natin, which is c is equals to cosine 30t over cosine 45. Then, substitute po natin yung value ng t na 439.23. Then, makukuha po natin ang ating c, which is 538 kilonewton. So, ang ating tensile force po dun sa cable is 439.23 kilonewton, and then yung c po natin is, or yung compressive force po natin is 538 kilonewton doon naman po sa boom. So next, problem 13. A cylinder weighing 400 kilonewton is held against a smooth incline by means of weightless rod AB. Determine the forces P and N exerted on the cylinder by the rod and the inclined perspective. So as you can see here in the diagram, meron po tayong 25 degrees and 55 degrees naman. 25 degrees dun po sa may weightless rod, and then 55 degrees dun po sa incline. So, for the solution, ito po, makikita po natin dito yung free body diagram, kung saan nasa quadrant 3 po natin ang 25 degrees at nasa may quadrant 4 naman po natin ang 55 degrees, and then our force or yung weight po nung cylinder is 400 kilonewton pababa. So, to solve, kunin po muna natin ang summation ng forces vertical. So, ito po, gagawin po ulit natin, katulad pong ginawa natin nung una. Gagawa po tayo ng dalawang equation para ma-solve po yung dalawa ding pong force na hinahanap, kasi hinahanap po natin ang N at saka P. So, using the summation of forces vertical is equals to 0, kung saan ang lahat po ng pataas ay positive at lahat naman po ng pababa ay negative. So, dito sa may N, the vertical force is cosine 55 degrees N. Naging cosine po siya kasi yung ang ating vertical force is adjacent dito po sa ating 55 degrees, plus dito naman po sa P, sine 25 degrees P, kasi po ang ating angle naman po ay, or yung force po natin is opposite po dun sa ating 25 degrees. Minus 400, yung pababa nga po nating weight is equals to 0. So, cosine 55 degrees N plus sine 25 degrees P, then transpose po natin yung negative 400 sa kabila para makuha po natin ang equation 1 natin. So, cosine 55N plus sine 25P is equals to 400. Yun po ang ating equation number 1. So, for our equation number 2, kunin naman po natin yung summation ng forces horizontal, kung saan lahat po ng pakanan ay positive at lahat po ng pakaliwa ay negative. And then, so as you can see, dito po sa N natin, ang horizontal force niya po is papunta po dun sa center, so or moving pakaliwa, so maging negative po, negative sine 55 N, naging sine kasi nga po siya ay adjacent, plus cosine 25 P is equals to 0, and then cosine 25 P is equals to sine 55 N. So isolating po ulit yung P para magamit po natin. So, P is equals to sine 55 degrees N over cosine 25 degrees. Para naman po sa ating equation number 2. And then, para mahanap na po natin si N tsaka si P, let's use the equation number 1 and equation number 2. So, in equation number 2, let's substitute the in equation number 1, we're going to use equation number 1 and then substitute P on the equation number 2. So, cosine 55n plus sine 25 degrees multiplied by the sine 55n over cosine 25 degrees is equals to 400. So, our n is equals to 418.61 kilonewton. And then, dahil po meron na po tayong n, substitute naman po natin to para hanapin natin si P. Para hanapin natin yung value ni P. So, dito po 'di ba sa equation number 2 natin, P na po yung hinahanap natin. So, gamitin po natin equation number 2 and then substitute the value of n which is 418.61 kilonewton. So, our P is equals to sine 55 degrees n over cosine 25 degrees. P is equal to sine 55 degrees multiplied by 418.61 which is the value of n over cosine 25 degrees. So, our P is 378.35 kilonewton. So, nahanap na po natin yung value ni P at saka ni n. Si P is 378.35 kilonewton and si n is 418.61 kilonewton. So, next is problem 14. The truss shown figure below is supported by a hinge at A and a roller at B. A load of 2,000 kN is applied at C. Determine the reactions at A at B. So, we will have two reactions or two forces acting on A kasi po fix ang support po sa kanya. So, meron tayong horizontal and vertical. At dito naman po sa B which is a roller or bearing po, so ang mag-act lang po sa kanya is isa, which is yung vertical force. So, for the solution, we have here our free body diagram. Then, first, let's solve for RB using the moment. So, mag-moment po tayo kay A para mahanap natin si RB. So, the summation of moment at A is equals to 0. Considering na lahat po ng pa-clockwise is positive and lahat po ng pa-counter is negative. Then, the unang force po na mag-act dito sa point C natin is yung cosine 30 multiplied by 2,000. Papunta po siya paganto kay A, so ibig sabihin po siya ay pa-clockwise. So, positive plus yung sine 30 degrees multiplied by 2,000 multiplied by 40. Pa-clockwise din po siya, so positive din po. Minus our RB kasi yung RB po natin, yung force po natin is pa-counterclockwise po multiplied by 30 which is its moment arm is equals to 0. Then let's isolate RB. So RB is equals to cosine 30 degrees multiplied by 2,000 multiplied by 15, the moment arm, plus sine 30 degrees multiplied by 2,000 multiplied by 40 which is its moment arm also over the 30. So, our RB is equals to 2,199.36 kilonewton. So, meron na po tayong RB. So, next po, dahil meron na po tayong RB, let's solve for RAV naman po, yung vertical force po natin kay A. So, we will use moment at O. Yung O po natin, consider po natin kasi 'di ba pwede po tayo mag-moment outside. So, dito po natin itapat siya sa may RB. So, at summation of moment at O is equals to 0. Lahat po ng pa-clockwise is positive, lahat po ng pa-counter is negative. So, as you can see po, yung RAV po natin ay pa-counter po papunta dun sa may point O natin. So, magiging negative po siya. So, negative RAV multiplied by 30 which is its moment arm plus cosine 30 degrees times 2,000 and then by 15 which is its moment arm. Positive po siya. Nag-plus po tayo kasi pa-clockwise naman po yung movement niya. And then, katulad din po dun sa may sine 30 natin multiplied by 2,000 multiplied by 10 which is its moment arm ay magiging pa-clockwise din po yung movement nila. So, is equals to 0. So, RAV is equals to cosine 30 degrees multiplied by 2,000 multiplied by 15 plus sine 30 degrees multiplied by 2,000 multiplied by 10 over 30. So, our RAV is 1,199.36 kilonewton. So, next that we have RAV and RB. Solve naman po natin yung ating horizontal force dun kay A. So, to solve for RAH, yung mga, igawin na lang po natin yung summation ng mga forces natin horizontal. So, the summation of forces horizontal is equals to 0, considering na lahat po ng papunta sa kanan is positive at lahat man po ng papunta sa kaliwa is negative. And then, so dahil po yung force RAH po natin ay papunta sa kaliwa, so negative po siya, plus cosine 30 degrees multiplied by 2,000 dahil papunta naman po siya sa kanan is equals to 0. And then, isolate lang po ulit natin, move po natin sa kabilang side, transpose yung negative RAH para maging positive po. So, RAH is equals to cosine 30 degrees multiplied by 2,000. So, cosine 30 degrees multiplied by 2,000 is equals to 1,732. So, yun na po yung magiging ating RAH. So, RAH is equals to 1,732 kilonewton. So, next is problem 15. Two cylinders A and B weighing 100 kilonewton and 200 kilonewton respectively are connected by a rigid rod curved parallel to the smooth cylindrical surface shown. Determine the angle alpha and theta that define the position of equilibrium. So, for the solution, meron po tayo ditong free body diagram kung saan makita po natin si A, B, at C. And then, also, ang una po natin gagawin dito is hanapin muna po yung sa angle. So, di ba po, ang angle po kapag sa semicircle is 180 or yung parang pinaka-horizontal po is 180 degrees. So, if meron po tayo dito sa ating left side na alpha, angle alpha, tapos meron din po tayo ditong angle theta, so ating gitna po is 90 degrees. So, we can use that to create our equation number 1. So, 180 degrees is equals to alpha plus 90 degrees plus angle theta. So, ang gawin po natin is si alpha po, ilabas po natin siya, or yun po yung hanapin natin. So, alpha is equals to 180 degrees minus 90 degrees minus theta. And then, 180 degrees minus 90 degrees is equals to 90 degrees. So, our equation number 1 is alpha or angle alpha is equals. So, for our next topic, which is equilibrium of parallel forces. Example number 1. So, here we have an example. So, dito po sa parallel forces naman po, kung mapapansin po natin, lahat lang po ng forces na nag-act dito is pa-vertical. So, here in example number 1, meron po tayong hahanapin na dalawang force which is RA and RB dito po sa magkabilang dulo po, dito sa may point A at point B. And then we also have here downward forces which is 60 kilograms, 78 kilograms, and 58 kilograms. Then also a distance of 2, 3, 2, and 4. So, for our solution, we will use moment. So, the summation of moment at A, dito po tayo mag-A para mahanap naman po natin muna si dito sa may reaction at B. So, using moment at A, the summation of moment at A is equals to 0 na lahat po ng pa-clockwise is positive, and then lahat naman po ng pa-counterclockwise is negative. So, kung ang movement po ngayon nito ni RB, kung titingnan po natin, ay pa-counterclockwise po para makapunta po siya kay point A. So, magiging negative RB multiplied by 11. Naging multiplied by 11 po kasi ang moment arm niya po is itong distance po na to. So, 2, 3, 2, at 4. So, 2 plus 3 is 5 plus 2 is 7 plus 4 is 11. So, kaya po ang naging moment arm niya is 11. Plus 58 multiplied by 7. So, naging plus 58 po kasi ang movement po nitong force natin na 58 kilograms, 78 kilograms, and 60 kilograms, kung mapapansin po natin, lahat po sila ay pa-clockwise. So, kung mapapansin nyo po dito, lahat po sila ay positive. So, naging 7 naman po yung multiply natin kay 58 kilograms kasi 2 plus 3 plus 2 is equals to 7. So, yun po ang kanyang moment arm. And then, plus po ulit, 78 multiplied by 5, which is the moment arm noon, which is 2 plus 3, kaya naging 5, plus 60 multiplied by 2, ito po yung moment arm niya. And then, isolate po ulit natin si RB. So, RB is equals to 58 multiplied by 7 plus 78 multiplied by 5 plus 60 multiplied by 2 all over 11. So, RB is equals to 83.27 kilograms. Next, dahil nahanap na po natin si RB, hanapin naman po natin si RA. So, using the moment at B, dito po tayo mag-moment ngayon sa B para mahanap natin si RA. So, kung mapapansin po natin, si RA ay mag-move pa clockwise papunta po kay point B, at si 60, 78 at 58 ay mag-move naman po pa counterclockwise, kaya magiging negative po sila dito sa ating mga equation. So, RA multiplied by 11, which is the moment arm, 2 plus 3 plus 2 plus 4 nga po, and then minus 60, ito po, dito, minus 60 multiplied by 9. Bali, naging 3 plus 2 is 5 plus 4 is equals to 9. Kaya yun po yung naging moment arm ni 60. And then, minus 78 multiplied by 6 kasi 2 plus 4 is 6. So, yun po yung distance ni 78 kilograms. And then, minus 58 multiplied by 4, which is yung moment arm naman po ni 58 papunta kay B, is equals to 0. So, isolate lang po ulit natin si RA dun sa kabilang side by pagta-transpose po, and then yung di-divide din po natin both sides by 11. So, RA is equals to 60 multiplied by 9 plus 78 multiplied by 6 plus 58 multiplied by 4 all over 11. So, ang ating RA po is 112.73 kilograms. So, yun po. So, next example number 2. The upper beam in figure is supported by a reaction at R3 and a roller at A, which separates the upper and the lower beam. Determine the value of the reactions at R3, R2, and R1. So, kung mapapansin po natin dito, parallel forces pa rin po siya, pero magkahiwalay po. Meron po tayong upper at saka lower beam. So, ang gagawin po natin pag-atake po dito para ma-solve natin yung R1, R2, at R3 ay unahin po muna natin isolve yung upper beam natin. So, first, as you can see here in our free body diagram, yung upper beam muna po unahin natin. So, makakuha po natin yon by magmo-moment po tayo dito kay A. Dito po sa tapat po ng ating roller. So, the summation of moment at RA is equals to 0, na lahat po ng pa-clockwise is positive, lahat po ng pa-counterclockwise is negative. So, ang movement po nito, kung makita nyo po, si R3 natin ay magiging counterclockwise po. So, magiging negative R3 multiplied by 10, which is, dito po natin makikita. Kung makikita po natin dito sa may ilalim din po, meron po tayong 4 meters nakatapat ng ating A. So, kung meron po ditong 4 meters, so ibig sabihin meron pa po ditong 6 meters. So, 6 plus 4, so equals to 10. So, kaya po nagkaroon tayo ng moment arm na 10 kay R3. And then, plus 1,900 multiplied by 6. So, nagkaroon naman po, naging positive naman po siya, or nag-add po tayo kasi ang movement niya po ay pa-clockwise. Minus 600 dahil ang movement po nito ay pa-counterclockwise multiplied by 4, which is yung moment arm na po, is equals to 0. So, our R3, isolate lang po ulit natin, and then by transposing to the other side, and then both sides i-divide po natin sa 10 para yun nga po, ma-isolate natin si R3. So, R3 is equals to 1,900 multiplied by 6 minus 600 multiplied by 4 over 10. So, ating R3 po is 900 kilonewton. Ngayon naman po, isolve naman po natin si ating RA. So, ngayon, na meron na po kasi tayo dibang R3. So, pwede na po talaga nating ma-solve si RA. O yung dito po sa may A natin, doon sa may roller. So, to solve naman po, mag-moment po tayo kay R3. So, the summation of moment at R3 is equals to 0. Lahat po ng pa-clockwise is positive, lahat po ng pa-counterclockwise is negative. So, RA multiplied by 10, which is ito nga po, ang ating moment arm, minus 1,900 dahil pa counterclockwise po ang movement ni 1,900 kilonewton papunta kay R3 multiplied by 4 which is our moment arm minus 600 multiplied by 14 kasi 14 kasi 10 plus 4 is 14 so yun po yung distance niya or yung moment arm niya and then ang movement niya po ay pa counterclockwise kaya naging negative. So, katulad po ulit ng ginagawa, isolate po natin si RA sa kabilang side. And then, maging RA po natin is equals to 1,900 multiplied by 4 plus 600 multiplied by 14 all over 10. So, ang ating RA is 1,600 kilonewton. Now that we have RA, we will use that to solve for the lower beam. So, for our lower beam naman po, as you can see, magkakaroon po tayo dito ng 1,600 kilonewton dito sa may dulo po ng ating lower beam. So, hanapin naman po muna natin si R2 natin by having a moment at R1. So, the summation of moment at R1 is equals to 0. Lahat po ng pa-clockwise is positive, lahat ng pa-counter is negative. So, kung titingnan po natin yung R2 natin papunta kay R1 is pa-counterclockwise kaya magiging negative po siya dito. So, negative R2 multiplied by its moment arm 10. Ito po. Plus, yung 4,000 po natin, papunta po siya kay R1 is pa-clockwise. Then, multiplied by its moment arm 4. Plus, yung 1,600 po natin na nasolve kay RA is pa-clockwise din po ang movement papunta kay R1. So, naging plus 1,600 multiplied by 14. So, 10 plus 4, 14. Kaya nagkaroon po siya ng moment arm na 14. So, lahat po yan ay equal to 0. So, isolate lang po ulit natin. So, R2 is equals to 4,000 multiplied by 4 plus 1,600 multiplied by 14 over 10. So, ang ating R2 po is 3,840 kilonewton. Ngayon na meron na po tayong R2, let's solve first, let's solve na po yung sa ating R1 kasi yun na lang po yung nawawala. So, para magawa po natin yon, mag-moment naman po tayo dito kay R2. So, pag nag-moment po tayo kay R2, so the summation of moment at R2 is equals to 0. Lahat po ng pa-clockwise is positive. Lahat ng pa-counterclockwise is negative. So, ang ating R1 po, kung titingnan po natin papunta po siya kay R2, mag-move po siya ng pa-clockwise. So, dahil pa-clockwise po, positive po siya. So, R1 multiplied by 10, which is its moment arm, minus 4,000 dahil ang movement naman po nito ay pa-counterclockwise multiplied by 6 which is dahil nga po meron dito sa side niya po na 4 and then yung haba po nito papunta kay R2 is 10 so 10 minus 4 is 6 kaya po nagkaroon tayo ng moment arm na 6 dito kay 4,000 plus 1,600 dito po sa ating nakuha kaninang RA dahil ang movement niya na po papunta kay R2 is pa-clockwise. So, naging positive po siya multiplied by 4 its moment arm. So, katulad lang po ulit, isolate po natin si R1 sa kabilang side. So, R1 is equals to 4,000 multiplied by 6 minus 1,600 multiplied by 4 is all over 10. So, makukuha na po natin ang ating R1 which is 1,760 kilonewton. So, next, example number 3. The cantilever beam shown in figure is built into a wall 2 meter thick so that it rests against point A and beam is 12 meter long and weighs 100 kilonewton per meter. A concentrated load of 2,000 kilonewton is applied at the free end. Compute the reaction at A and B. So, ito po. As you can see here in the figure. So, meron po tayo ditong uniform load. So, to solve for our RB, magmo-moment po tayo dito kay A. So, RB, kung papunta po siya dito kay A is movement niya po ay pa-clockwise. So, RB, naging positive, multiplied by 2 which is its moment arm minus 2,000 dahil ang movement naman po ng 2,000 ay pa-counterclockwise multiplied by 12. So, ito po yung distance niya, yung moment arm minus 100 multiplied by 12 multiplied by 6. So, dahil nga po ang ating distance po or yung pinaka-length po ng ating beam is 12 meters. And then, we have ito pong 100 kilonewton per meter po na beam natin, which is a uniform load. Diba? Pag uniform load po, kailangan po natin i-multiply yung load natin dun sa distance natin. So, 100 multiplied by 12 and then multiplied by 6 again because of the moment arm. So, ayun po. And then, mayari po dito, isolate lang po ulit natin si RB. So, RB multiplied by 2 minus 2,000 multiplied by 12 minus 100 multiplied by 12 multiplied by 6 is equals to 0. And then RB is equals to 2,000 multiplied by 12 plus 100 multiplied by 12 multiplied by 6 all over 2. So, our RB is 15,600 kilonewton. Then, meron na po tayong RB. Ngayon naman po, ang gawin po natin, hanapin po natin si RA natin o yung reaction dun sa point A natin. Para naman po magawa natin yon, mag-moment po tayo dito kay RB. So, the summation of moment at B is equals to 0. So, yung RA po natin, papunta kay B is moving clockwise. So, positive multiplied by 2, which is its moment arm, minus 2,000 na, naging minus po siya kasi ang movement niya po is pa-counterclockwise, multiplied by 10, which is its moment arm, minus 100 multiplied by 12 multiplied by 4. Katulad po ulit ng sinasabi ko, dahil nga po uniform load siya, kailangan po natin i-multiply yung ating load dun sa ating distance na 12. So, 100 multiplied by 12 multiplied by 4 is equals to 0. Then, para makuha po natin to, labas po ulit natin si RA. And then, labas din po natin si, sa kabilang side naman po yung iba. So, RA is equals to 2,000 multiplied by 10 plus 100 multiplied by 12 multiplied by 4 all over 10. So, ang ating RA po is 12,400 kilonewton.
So, let's proceed to our example number 4. If each pulley shown in the figure weighs 36 kilonewtons and our force W equals to 720 kilonewtons, then we must find our P to maintain our equilibrium. So, our first step in solving this equation or this example is to divide our figure into two free body diagrams. So, in our first free body diagram, number 1, we divide our biggest pulley and then we cut it off, showing us 3 new forces. So, these forces, we name them P1s, and since they are all positive going up, then they are positive sign. So, and then we have our W or our weight of our pulley equal to 36 kilonewtons going down because it's weight. And then a force W going down as well equal to 720 kilonewtons. So, our equation would be summation of our force vertical, positive going up and negative going down, equal to 0. So, in our equation, we have 3 P1s as we can see, and then our weight of our pulley, which is 36, which is going to be negative because it's going down, and then our force W would be equal to negative as well because it's going down, equal to 0. So, we have 3 P1s minus 720 minus 36 equal to 0. And then, the next step would be to sum up all of our P1. So, it will be 3 P1 minus 720 and minus 36 equal to 0. Our next step is to transpose our negative signs or our negative forces to the right side to turn their signs into positive. So, now we have 3 P1 equal to 720 plus 36. But to get only our P1, we need to divide it by 3 both sides. So if we do that, we have 756 divided by 3, which leads us to the answer of P1 equals to 252 kilonewtons. So therefore, we are moving on to our second free body diagram to get our P. Then in this P, we simply just divide again our diagram into 3 positive forces again. So we call this P2s, and our calculated P1 is going to be our weight going down, and we include also the weight of each pulley. So now our formula would be positive arrow up and then negative going down to then our summation of our force vertical equal to 0. So summation of forces vertical, our P2s going up, so they are positive signs, and then our forces P1, which going down, equals to 252 as we solved earlier, and as we all know that the weight of each pulley is equal to 36, so that would be going down as well. So negative 36 equal to 0. Then the next step which we do is to add all the 3P, P2 equal and then we have 3P2. Then we minus our sign, our weight of our P1, which is 252, minus the weight of our pulley, which is 36. So we have now 3P2 minus 252 minus 36 equal to 0. And then, as we know earlier, our next step would be to transpose our negative 52 and negative 36 to the right side to turn their signs positive. And then now we have 3P2 equal to 252 plus 36. Then our next step is to divide both sides by 3 in order to just have our P2. So now our P2, our 288 divided by 3 would give us our 96 kilonewtons. So now we have 52 P2 equals to P, resulting for our P2 equal to 96 kilonewtons. So let's proceed to our next topic, which is the equilibrium of non-concurrent forces. So for our example 1, the uniform rod in the figure weighs 420 kilonewton and has its center of gravity as G. Determine the tension in the cable and the reactions at the smooth surface at point A and B. So we are here to task to determine the tension of the cable and the reactions at point A and point B. So example number 1, we would rely on our sine law and cosine law. As we can see, it's a triangle at our free body diagram. So at first, we have our sine 45 degrees equal to our 8 over C because it is our so equals to sine, our opposite, which is 8, and our hypotenuse, which is our C. So C, cross multiplication, we have C equals to 8 over sine 45 degrees, which equals to 11.31. Now we use our cosine law, which is y equals to square root of 11.31 squared plus 11.31 squared, leading us to our conclusion of our y being 16. So moving forward into our solution, we have a clockwise positive summation of our moments equal to 0. So our first moment, which would be T, or our tension, equals and its moment being 14 plus 420, which is our force of the rod, and its summation being 6 equal to 0. Now, if we transpose our T to the right side, we become positive T 14 multiplied by 14, and then T, to segregate our T only, we divide it both sides by 14, leading us with T equals to 420 multiplied by 6 over 14, leading us with our tension force being 180 kilonewtons. Then moving, we have our clockwise positive summation for our moment A equal to 0. So we are going to moment at our A. So we start with our force RB, which would be negative, and its moment arm would be 11.31 or our C, plus 420 or the force of the rod. Again, its moment arm is just 6, plus our moment of our tension, which is 180, and then its moment arm would be 2, equal to 0. So now, since we're going for RB, then we put that on the right side, and then we divide our equation both sides by 11.31 to just leave us with RB. So that would be RB equals to 420 multiplied by 6 plus 180 multiplied by 2 over 11.31, leading us to our RB being 254.64 kilonewtons. Then up next, we have our clockwise positive summation for our moment B. So at B, our moment now would start at B equal to 0. So our RA, its moment arm would be 6 plus 2, which equals to 8. Then our tension force, which would be negative now, would be equal to 180 multiplied by 6, which is its moment, minus 420, which is our rod, and its moment would be 2, equal to 0. Now that we're looking for RA, we put that on the right side, switching its sign. Now that we move our forces to the right side, we have RA equals to 180 multiplied by its moment 6 plus 420, or which is the force of our rod, multiplied by its moment 2 over 8. And then if we sum up, put that in our calculator, and we have a result, we would equal to RA equals to 240 kilonewtons. So moving on, we have our example 2. Determine the load P required to hold the bar AB in a horizontal position on the smooth incline shown in figure. Also determine the reaction at A and B. So we are going to determine the load P as well as the reaction at A and B. So example number 2, following it, we have C over sine 45 degrees equal to 20 over sine 105 degrees. So it's 105 degrees because it's 60 degrees plus 45 degrees. Then we have our C, which is a result of our cross multiplication. We have C equals to sine 45 degrees multiplied to 20 over sine 105 degrees. So we have our C equal to 14.64. Then moving forward in our equation, we have our moment OB equal to 20 over sine 30 degrees and sine 105 degrees. Our OB would equal to 20, cross multiplication, our OB would equal to 20 sine 30 degrees over our sine 105 degrees, which leads us to our OB being equal to 10.35. Then our cos 30 degrees equal to our x1 over 14.61. Our C1 would now equal to our cos 30 degrees multiplied by 14.61, and our C1 would equal to 12.68. And then our x would equal to 12.68 minus 4, which lead our x to be 8.68. Then now we have our summation of moment. Always clockwise is positive, equal to 0. So our P, which is counterclockwise, would be negative P, and its moment arm would be 8.68 as we computed earlier, plus 400, and then its moment arm would be 5.32, equal to 0. And then as we segregate this, we move P to the right side, turning its sign into a positive, and then to segregate our P only, we divide both sides by 8.68, and then that leads us to our P being equal to 245.16 kilonewtons. Then moving forward, we have clockwise positive moment at our B equal to 0. So our RAV versus RAV, and its moment would be equal to 20, and then our negative 245.16 versus, it would be negative because it's counterclockwise, and then its moment would be 16, which is 14 plus 2, and then it would equal as to negative 400 multiplied by 2 equal to 0. Then our moving forward, our AV would equal to our 245.16, and then its moment arm, which is 16, plus our 400 multiplied by 2, and that's our forces when they are transposed to the right sides and their signs change. And then we divide it easily by 20 to segregate our RAV, which leads us to our RAV being 236.13 kilonewtons. And then to get our RA, we just simply cos 60 degrees, which is the original degree, equal to 236.13 as we computed earlier, divided by our RA. And then cross multiplication would lead us to our RA equal to 236.16 over cos 60 degrees, would then equal to our RA being 472.26 kilonewtons.
Under analysis of structure, meron tayong method of joints. Meron tayong dito ang example. Determine the force of all members. Meron tayo dito ng truss na merong 7 joints. Joint A, joint B, joint C, joint D, joint E, joint F, joint G, at joint H. Pwedeng di sunod-sunod yung joint na yan sa pagpa-plot niya. Meron tayong 600 kN na nakalagay sa joint C, 1,000 kN na nakalagay sa joint E, at 400 kN na nakalagay sa joint G. Bago natin ma-plot yung RA or yung resultant A at resultant H, kailangan muna natin malaman yung mga chord. Meron tayong tatlong uri ng chord, yung top chord, bottom chord, tsaka member. Yung top chord meron siyang AB, BD, DF, tsaka FH. Yung sa bottom chord merong AC, CE, EG, GH. Tapos yung sa member, may 5 siyang member. Yung BC, BE, DE, FE, tsaka FG. So, kukunin natin yung bawat value ng chords na yun. Pero bago yun, kukunin muna natin yung resultant A tsaka resultant H. Para makuha yun, gagamit tayo ng equilibrium. So, gagamit tayo ng moment. Sa pagkuha ng resultant A, magmo-moment tayo sa H. So, summation ng moment of H, clockwise pag positive at negative naman pag counterclockwise. So, yung RA meron siyang moment arm na 40. So, positive siya kasi clockwise yung direction niya. Tapos, yung 600 meron tayong moment arm na 30. Negative siya kasi counterclockwise. 1,000 yung sa 1,000 is may moment arm siyang 20, tapos counterclockwise siya, so negative. Then yung 400, may 10 siya na moment arm. So magiging negative siya kasi counterclockwise din yung direction. Equals 0. So i-divide natin iyon sa 40 na yung moment arm ng RA para makuha yung value ng resultant A. So magiging resultant A or RA is equals to 600 times 30 plus 1,000 plus times 20 plus 400 times 10 over 40. So the value of RA will be 1,050 kilonewton. Then para makuha naman natin yung value ng RH is mag-moment tayo dun sa kabila naman, dun sa A. So summation of moment of A clockwise positive and counterclockwise negative equals to 0. So yung RH is magiging negative siya kasi counterclockwise siya dun sa yung direction niya, and yung magiging moment arm niya is 40. Tapos yung 600 meron siyang moment arm na 10, tapos positive siya kasi clockwise siya. Tapos yung 1,000 meron siyang 20 na moment arm, tapos positive siya kasi clockwise din siya. Tapos yung 400 meron siyang moment arm na 30 and positive siya kasi clockwise siya, and it is equals to 0. So, i-divide ulit siya sa moment arm ng RH which is 40. Tapos, ang magiging result is RH is equals to 600 times 10 plus 1,000 times 20 plus 400 times 30 all over 40. So, the value of RH would be 950 kilonewton. So, nung nakuha na natin yung value ng RA at RH, is dadaw naman tayo dun sa mga members. May choice tayo kung saan tayo pwedeng magsimula. Either dun sa joint A or dun sa joint H. Kasi parehas naman silang may value na ng resultant A tapos yung resultant H. Tapos ang hinahanap na rin lang naman natin is yung mga members or yung mga chords niya. So dun sa joint A, meron tayong AB, AC, tapos yung resultant A natin at 1,050 kilonewton. Mag-a-assume tayo na yung AB is compression, then yung AC is tension. So, mag-summation of forces vertical tayo, which is pag pataas is positive and pag pababa naman is negative. So, summation of forces vertical is equals to 0. Tapos yung 1,050 na pataas siya, so positive siya. Tapos sin 30 degrees yung sa AB since pababa naman siya. So, yung angle nga pala nung trusses natin is perfect 30 degrees. So, lahat sila is equals sa 30 degrees na angle. So, itatranspose natin yung sin 30 degrees dun sa kabila para mawala yung AB dun sa value. So, sin AB is equals to 1,050. Then, yung AB is equals to 1,050 tapos itatranspose yung sin dun sa baba, i-divide para maging sin 30 degrees. So, AB is equals to 2,100 kilonewtons. So, tama yung assumption natin na compression siya since nag-positive siya. Then, yung next naman is forces horizontal. So, summation of forces horizontal, pagpa kanan is positive, then pagpa kaliwa is negative. So, yung AC na inassume natin na tension, so, pa kanan siya, so positive. Tapos, yung cos 30 degrees is magiging negative siya. Tapos, yung moment arm niya is 2,100. So, yung AC, itatranspose natin sa labas, magiging AC is equals to cos 30 degrees times 2,100. So, ang magiging value ng AC is 1,818.7 kN. So, tama rin yung assumption natin na tension since nag-positive siya. So, after natin makuha yung joint A, is dediretso naman tayo sa joint C. Bakit hindi joint B? Kasi joint C, yung dalawa lang yung kulang niya. So, yung sa joint B is tatlo yung kulang niya. Kaya, magdediretso muna tayo sa joint C. Sa joint C, meron tayong BC, CE, AC, tsaka yung C. So, yung AC natin is yung nakuha natin kaninang 1,818.7 kN, which is tension. Then, yung C natin na yung 600 kN na tension din. So, i-assume natin na yung BC is tension din and yung C is tension din. So, magsusummation forces vertical tayo at summation forces horizontal. Sa summation forces horizontal muna tayo. So, summation forces horizontal, positive pagpakanan at negative pagpakaliwa. So, yung CE, isa lang naman yung horizontal dun sa figure. So, yun yung value ng AC natin na 1,818.7. Then, pakaliwa siya, so naging negative. So, yung CE, transpose lang natin sa, yung 1,818.7, transpose natin sa labas para yung maging positive. Then, yung CE is equals to 1,818.7 kN. So, tama yung assumption natin na tension. Next is magsa-summation forces vertical naman tayo, which is pataas is positive and negative naman pag pababa. So, yung C na 600 is pababa siya, so negative. Tapos yung BC na pataas, inassume natin na tension, so positive siya. So, BC is equals to 600 kN, so tama din yung assumption natin na tension. So, pwede na tayong dumiretso sa joint B. Sa joint B, makikita natin dalawa din yung missing. So, ang mangyayari dito is yung magkakaroon tayo ng equation 1 and equation 2. So, summation forces horizontal muna tayo, which is kapag positive pagkanan and negative naman pagkakaliwa. So, meron tayo sa joint B, meron tayong BD, BC, BE, and AB. So, assume natin na yung BD is compression and yung BE naman is also compression. So, yung BD natin na may 2,100 cosine 30 degrees, kanan siya, so kaya magiging positive. Then, yung BD cosine 30 degrees natin is pakaliwa, so magiging negative siya. Tapos, yung BE natin na pakaliwa din is magiging negative, so magiging B is cosine times cosine 30 degrees. So, para makuha yung BD natin is i-divide yung 2,100 cosine 30 degrees minus BE cosine 30 degrees sa cosine 30 degrees. So, cancel yung mga cosine 30 degrees. Ang matitira is BD is equals to 2,100 minus BE. So, yun yung magiging equation 1 natin. Next is magsusummation forces vertical tayo, which is pagpataas is positive and pagpababa is negative. Yun pa rin, yung 2,100 na value, tapos is-sin 30 degrees naman siya, magiging positive siya kasi pataas, tapos negative naman yung 600 kasi pababa. Plus yung BE sin 30 degrees natin, magiging positive siya since pataas, then yung BD sin 30 degrees is magiging pababa since magiging negative since pababa siya. So, 2,100 times sine 30 degrees minus 600 plus BE sine 30 degrees minus BD sine 30 degrees. So, yun yung magiging equation 2 natin. So, equation 1, isa-substitute natin siya sa equation 2. So, yung 2,100 ay yung BD natin, isa-substitute natin dun sa equation 2 natin. So, magiging 2,100 sine 30 degrees minus 600 plus BE sine 30 degrees minus 2,100 minus BE sine 30 degrees is equals to 0. Tapos, pag kinompute natin yon is ang kakalabasan is BE is equals to 600 kilonewton and nag-positive siya, so tama yung assumption natin na compression yung BE. Then yung sa BD naman is isa lang naman, dalawa yung natira, yung BD 2,100 minus BE. Di ba yung nakuha nating value ng BE kanina is 600, so sa-substitute lang natin yun dun sa equation 1, so magiging BD is equals to 2,100 minus 600. So, BD is equals to 1,500 kilonewton. So, positive din siya. So, tama yung assumption natin na compression siya. Next is yung joint D naman natin. Yung sa taas na part. So, ganun din yung gagawin natin. Summation forces horizontal at summation forces vertical. So, unahin natin yung summation forces horizontal. Sa joint D natin, meron tayong DF, DE, tsaka BD. Yung DF natin is compression. Assumption natin yung Leon. Tapos DE is tension. And yung BD is compression, since yun yung nakuha natin kanina na value sa BD. So, summation forces horizontal muna tayo. So, summation forces horizontal, positive pagpakanan, negative naman pagpakaliwa. So, yung cos 30 degrees, times siya sa 1,500, since yun yung moment arm niya, minus DF cos 30 degrees equals 0. Then, itatranspose yung magkaparehas. Yung, bali, magiging cos 30 degrees, DF equals cos 30 degrees, 1,500. So, ilalabas yung DF, tapos yung cos 30 degrees niyang katabi is ilalagay sa denominator. So, magiging DF is equals to cos 30 degrees times 1,500 over cos 30 degrees. Then, pag kinompute siya is, ang kalalabasan is, yung DF is 1,500 kilonewton. So, nag-positive uli siya, so compression. Tama yung assumption natin na compression siya. Then, we have summation forces vertical, na kapag pataas is positive, then pagpababa is negative. So, yung DE natin, is pababa, so magiging negative siya. Then, yung sine 30 degrees times 1,500 is magiging positive since pataas siya. Then, sine 30 degrees times 1,500, positive uli siya since pataas siya. Then, pag inilabas yung DE dun sa equation is magiging DE is equals to sine 30 degrees times 1,500 plus sine 30 degrees times 1,500. Pag kinompute yung value nun is magiging DE is equals to 1,500 kN tension. So, tama din yung assumption natin. Nag-positive siya. So, doon na tayo sa joint H, joint G, at joint F. So, bali bago pumunta doon is, di ba, kanina nasabi ko na pwedeng magsimula tayo sa joint A or sa joint H. Ngayon, nakuha na natin yung other side ng trusses, so pwede na tayong pumunta doon sa kabilang side. Yung joint H muna tayo. So, positive, magsusummation forces ulit tayo, summation forces vertical, tsaka summation forces horizontal. Simulan muna natin sa summation forces vertical. Bali yung joint H, meron siyang mga chords na FH, GH, tsaka RH. So, i-assume natin na yung FH is compression, then yung GH is tension. Yung RH natin is may value na siya na kanina na 950 kN. So, magsimula muna tayo sa summation forces vertical. Pagpataas, positive, and then pagpababa is negative. So, yung 950 natin, pataas siya, so magiging positive. Then, yung sin 30 degrees, FH natin, is magiging negative. Kasi pababa yung direction niya. So, itatranspose natin yung FH sa labas. Then, ilalagay natin yung sin 30 degrees as a denominator. So, FH is equals to 950 divided by sin 30 degrees. So, pag kinompute natin yun, is magiging FH is equals to 1,900 kilonewton and compression siya. So, tama rin yung assumption natin na compression. Then, summation forces horizontal naman tayo, which is kapag pakanan is positive, then pag pakaliwa is negative. So, yung GH natin na pakaliwa is magiging negative siya. Tapos, yung cos 30 degrees times 1,900 natin is pakanan siya, so magiging positive. Kapag nilabas natin yung GH dun sa equation, magiging GH is equals to cos 30 degrees times 1,900. So, yung GH, pag kinompute natin, is magiging 1,645.5 kilonewton. So, tama din yung assumption natin na tension siya. So, nag-positive siya. Next is yung joint G. Sa joint G naman is ganun din yung gagawin natin. Summation forces vertical tsaka summation forces horizontal. So, simula muna tayo sa summation forces vertical, which is kapag pataas is positive, then kapag pababa is negative. Sa joint G natin, meron tayong apat na chords, yung F, G, E, C, tapos yung 400 kN, tapos yung 1,645.5 kilonewton na nakuha rin natin kanina dun sa GH. So, yung FG tsaka EC is mag-a-assume tayo na parehas silang tension. So, yung summation forces vertical natin na 400 kilonewton na tension is pababa siya, so magiging negative. Tapos yung FG natin na inassume natin na tension, tapos pataas yung arrow niya is naging positive siya. So kapag nilabas natin yung FG, yung negative 400 dun sa equation is FG is equals to 400 kilonewton, which is nag-positive. So tama uli yung assumption natin na tension siya. Next is dun tayo sa summation forces horizontal, which is kapag pakanan is positive, then pag pakaliwa is negative. Yung EG natin na pakaliwa is magiging negative siya, tapos yung 1,645.5 na value ng GH natin is positive since pa kanan yung arrow niya. Pag nilabas yung EG dun sa equation, magiging EG is equals 1,645.5 kilonewton, then positive uli siya, so tama uli yung assumption natin na tension siya. So, dun sa last is joint F na isa na lang yung kulang natin na value, which is yung nawawala nating FG. So, ang mga doon is yung 1,500, which is compression siya, yung FE, compression, yung FG na inassume 4,000 siya, tapos tension, tapos FH na 1,900 na compression. Sa joint F is magpo-forces horizontal, summation forces horizontal tayo, which is kapag pakanan is positive, then pag pakaliwa is negative. So, yung cos 30 degrees, EF natin is positive siya kasi pakanan siya, tapos yung cos 30 degrees natin times 1,500 is pakanan din siya, so positive, minus yung cos 30 degrees natin 1,000 times 1,900 na naging negative since pakaliwa yung arrow, yung direction niya. Then, kapag nilabas natin yung EF dun sa equation, is magiging EF is equals to cos 30 degrees times 1,500 minus cos 30 degrees times 1,900 divided by dun sa katabi ng EF kanina na cos 30 degrees. So, magiging divisible, ay divisor siya ng equation natin. So, pag kinancel out yung cos 30 degrees sa bawat equation is magiging EF is equals to 1,900 minus 1,500. So, kapag kinumpute natin siya, is magiging EF is equals to 400 kilonewton, which is nag-positive. So, compression siya and tama siya. So, nakompleto na natin yung mga members dun sa trusses natin. So, para magamit natin siya is kailangan kumuha tayo ng pinakamataas na load sa bawat type ng members natin, which is yung sa top chord, sa bottom chord, tsaka sa member. Yung sa top chord, meron tayong pinakamalaking load na 2,100 kilonewton, sa bottom chord is 1,818.7 kilonewton, and sa member is 1,500 kilonewton na tension. So, yun yung gagamitin natin na basehan since yun yung pinakamataas na load. And yun lang po.
Also, for analysis of structure, we also have method of section. So, sa method of section, gagamitin natin yung same example na ginamit sa method of joints. But, dito, gagamit tayo or i-identify natin yung forces nila gamit yung mga members. So for example problem of method of section, here is the problem. So, using the method of sections, determine the force in members BD, BE, and CE. So, but before that, i-identify muna natin which part of the triangle yung gagamitin natin or yung gagamitin natin as section. It's either left or right. Since magde-decide tayo na gagamitin natin yung left, yun yung isi-section natin. But first, kukunin muna natin yung reaction. Since may nakuha na tayong reaction gamit yung method of joints, yun na lang yung ilalagay natin sa na-section natin na part ng triangle. Ang kukunin natin is yung reaction ng A, which is RA is equals to 1,050 kilonewton. So, since nag-section nga tayo, may tatamaan yung mga members or lines. Ang tatamaan is si member CE, PE, and BD. Since after natin mag-section, mag-a-assume tayo kung it's either yung members ba natin is tension or compression. I-assume natin sa member CE na siya ay tension. Tapos dun sa member BD naman, i-assume natin na siya ay compression. Ang tension is papalayo, while yung compression naman is papasok. If the value na makukuha natin sa dalawang member na to ay magiging negative, meaning yung assumption natin ay baliktad. Since tinamaan nga din si members BE, i-assume na natin na siya ay pa-compressed din. But before that, kukunin muna natin yung moment arm ni line BC at saka ni line DE by using triangle method. So, i-isolate muna natin si triangle ABC na may 10 meter na base. So, kailangan natin makuha yung length ng line BC. So, to get that, gagamitin natin yung tangent 30 degrees is equals to BC over 10. Since meron tayong base na 10 meters. So, BC is equals to tangent 30 degrees multiplied by 10. Yung lalabas na length ng line BC natin is equals to 5.774 meters. Ganun din yung gagawin natin sa line DE, which is tangent 30 degrees is equals to DE over 20 since ang triangle na in-isolate natin is triangle ADE. So, DE is equals to tangent 30 degrees multiplied by 20. Saan galing yung 20? Yung 20 is galing dun sa 10 meters by 10 meters na nasa baba. So, bali, ang line DE ay magiging 11.55 meters. So, unlike sa method of joints na gumagamit ng summation of forces vertical and summation of forces horizontal, dito gagamit tayo ng summation moment is equals to 0. So, para makuha natin yung forces or yung force sa member CE, mag-summation tayo or mag-summation tayo sa moment B. So, since CE multiply by sa moment arm niya na 5.774, which is counterclockwise, magiging negative, plus dun sa reaction natin na RA, which is 1,050, ang moment arm naman niya ay 10, magiging is equals to 0. So, i-isolate lang natin yung CE. So, magiging CE is equals to 1,050 multiplied by 10 over 5.774. So, yung CE ay magiging equal sa 1,818.5 kilonewton, which is tension. So, kung ika-countercheck natin to sa method of joints, same sila ng answer. Next naman natin is kukunin para naman dun sa member BE, since isa din siya sa mga tinamaan. So, but before that, kukunin muna natin yung forces para dun sa BE vertical, since hindi naman natin agad yun makukuha. Since kulang nga tayo ng forces. So, first, gagamitin ulit natin yung summation moment A is equals to 0, which is yung meron ditong 600 multiplied by 10, which is yung moment arm niya, minus sa BE vertical multiplied by 20, which is yung moment arm, is equals to 0. So, isolate na ulit natin yung BE vertical. So, ang makukuha natin is 600 multiplied by 10 over 20. So, yung BE vertical natin ay equivalent sa 300 kilonewton. So, para makuha natin yung BE, gagamitin natin yung angle na 30 degrees, which is para makuha natin, sin 30 degrees is equals to 300 over BE. I-isolate natin yung BE, which is makukuha natin is 300 over sin 30 degrees. So, yung BE is equals to 600 kilonewton, which is compression. So, kung ika-countercheck ulit natin to dun sa method of joints, same tayo ng nakuha. And lastly, para na makuha natin yung last member na tinamaan ng pag-section natin, which is yung member BD, gagamit tayo ng magmo-moment tayo sa joint E, which is summation moment ME is equals to 0. So first, kukunin natin yung BDH, since wala tayong or yung BD horizontal, since yun yung nawawala nating forces or moment. So yun, kukunin natin. Since yung BDH is counterclockwise, na may moment arm na 11.55, so negative BDH multiply by 11.55 plus yung sa RA natin, which is clockwise, magiging plus 1,050 multiplied by 20 minus 600 multiplied by 10 is equals to 0. So, i-isolate natin yung BDH, ililipat lang natin sa kabila para maging positive. Ang makukuha natin is 1,050 multiplied by 20 minus 600 multiplied by 10 over 11.55. So, yung makukuha nating forces or yung force na makukuha natin para sa BDH ay magiging equivalent sa 1,298.7 kilonewton. And lastly, para makuha natin yun, gagamit naman tayo ng cosine 30, which is yung angle na meron tayo, or angle na given. So, cosine 30 is equals to 1,298.7 over BD. So, isolate natin yung BD. So, BD is equals to 1,298.7 over cosine 30 degrees. So, makukuha natin is BD is equals to 1,499.609 kilonewton, or kapag i-round off natin, magiging 1,500 kilonewton, which is also compression. So, kapag check natin yun dun sa method of joints, makukuha natin is the same, or 1,500 kilonewton. So, ma-assume natin dito na tama yung assumption na ginamit natin kahit pa hindi natin ginamit yung method of joints.
Then following up the methods of sections, now we have dynamics of rigid bodies. So to explain, we have our example 1. On a certain stretch of track, trains run at 60 km per hour. How far back of a stop train should a warning torpedo be placed to signal an oncoming train? Assume that the brakes are applied at once and retard the train at the uniform rate of 2 feet per second. So now we are looking for the distance of how far our warning torpedo should be placed to signal the upcoming train. So to solve this equation, our first move would be to convert our velocity. So now we have V equal to our 60 kilometer per hour multiplied by 1,000 meter over 1 kilometer to cancel out our kilometer. And then to transform our meter now into our feet, we multiply it by 3.28 over 1 meter. And then for our hour to be converted into seconds, we multiply it by 1 hour over 3,600 seconds. And that would lead us to our velocity being equal to 54.67 feet per second. Then, moving forward in the equation, now we have to use the formula, our final velocity squared equal to our initial velocity squared minus 2 acceleration and distance. So now since our final velocity would equal to 0, we have 0 equal to our initial velocity minus our 2 acceleration and then our distance. Now, we transpose our negative 2 acceleration and distance to the left side to turn it positive, leading us to our equation initial velocity squared equals to 2 acceleration and then distance. But since we are just looking for our distance, we divide both sides by 2 acceleration, leading us to s equal to v initial velocity squared over 2 acceleration. So now our s is equal to our converted velocity, which is 54.67 squared, equal to our 2, and then our acceleration, which our uniform rate acceleration, which is 2, leading us with our distance to be 747.20 feet, since we cancel out our second. Then still moving on our dynamics, we have our example number 2. A ship being launched slides down away with a constant acceleration. She takes 4 seconds to slide the first meter. How long will it take to slide down the way if their length is 900 meters? Okay. So our chosen formula for this is s equal to our initial velocity multiplied by time plus our at squared over 2. Now, since our initial velocity is 0 multiplied by time, then we'll just cancel out that part of the equation. So now we have s equal to our acceleration multiplied by our time squared over 2, which leads us, and then let's substitute our values into our formula. So now we have 1 meter equals to our acceleration, which is a, multiply by our 4 seconds squared over our 2. And that would lead us, cross multiplication would lead us to our acceleration equals to 2 over 4 squared. And that would lead our acceleration to be 0.125 meter per second squared. Then moving forward in the equation, we have s equals at squared over 2. Now we're looking for our 900 meters. So we substitute the distance to 900 meters equal to our acceleration, which is 0.125 or 0.125, and then our time squared equals to divided by 2. So now we're looking for our time. So we just cross multiply that, and then we square the equation. So we have t equal to the square root of 900 times 2 divided by 0.125, leading us to our time to be 120 seconds. So that's how long a boat takes to slide down 900 meters. Now, to explore dynamics even further, let's proceed to example number 3. Two cars A and B have a velocity of 25 meters per second in the same direction. A is 73.5 meters behind B, so A is behind, when the brake is applied to car B. So our car B stopped, causing it to decelerate at a constant rate of 3 meters per second squared. Number 1, in what time will A overtake B? Number 2, how far will car A travel? And 3, how far will car B travel? So we are tasked here to find the time that will take car A to overtake car B. How far will car A travel, and how far will car B travel? Now, our car A, the formula for that is our s equals to velocity times time, which is would just be equal to s equal to 25 multiplied by t, since we have no time yet. So that would be equal to our equation 1. Now, to solve this, we need to move on and look at car V now. So car V, it equals to s, or its distance, equal to its initial velocity multiplied by time minus its acceleration multiplied by time squared over 2, and that would lead us to our distance b equals to 25 multiplied by t minus 3 t squared over 2, and that would be our equation number 2. And then SA equal to 73.5 plus SB, which equals to our equation number 3. Since that is how we will find the distance for car A and then car B. Now moving further along, we have for S multiply. Let's focus on equation number 3. So now we have SA equals 73.5 plus SB. So now we know that our distance A, or our SA, is equals to 25 multiplied by T, and then our SB is equal to 25T equals 25T minus 3T squared minus 2. Since we can see that there are 25 multiplied by T, it would be canceling each other out, since we move 125T to our left side. So now our equation shall look like 0 equal to 73.5 minus 3t squared over 2. Now, we need to solve for time, so we need to segregate our t. So to do that, we just need to cross multiply it. So now we have t equals to square root of 73.5 multiplied by 2 divided by 3. And that shall lead us with our time being equal to just 7 seconds. So we need to look at our equation 1 again to find out the distance of A and the distance of B. Now we have our distance of car A equals to 25 multiplied by T, and now we have just 25 meter per second multiplied by 7 seconds. Cancelling each second would lead us to 175 meters. So that is how far car A will travel. And then moving forward to car B, we just have SB equal to SA minus 73.5. So the total distance of our car B shall be equal to 175 meters, as we computed earlier, minus 73.5, which is our converted distance earlier. So now we have for distance that traveled by car B, we have 101.5 meters. So that's all for that example. Now, let's move on to free-falling objects. So for free-falling, we have example number 4. A ball is dropped from the top of a tower 80 feet high. At the same instant, a second ball is thrown upward from the ground with an initial velocity of 40 feet per second. Now we are tasked to determine when do they pass each other, or the time, and then where do the pass from the top of the bottom tower. So to solve this equation, let's proceed to example 5, free-falling bodies. So our first ball, we're going to use the this equation, our h1 equal to our initial velocity times time, plus our g, or our gravity, multiplied by our t squared over 2. And since the velocity here is 0 multiplied by time, so we just cancel that out. And now we have our h1 equals to gt squared over 2, and that should be our equation number 1. Then need to look forward and then look at our ball 2. So the height of our second ball equal to the velocity times time minus our gravity times squared over 2, and that shall be our equation number 2. And then for equation number 3, we have h2, or our height 2, equals to 80 minus h1, and that should be our equation number 3. Now, let's solve this. We have our initial velocity multiplied by time minus gt squared over 2 equals to 80 minus gt squared minus 2. You see that we use the formula right here, which is 80. We just substitute our h2 with equation number 2. And that shall lead us with our initial velocity with VOT equals to 80. And now we know that we are just looking for our time. So we divide both sides by 40, which is our initial velocity. So that will lead us to our time being equal to 2 seconds. And now to find the height, the first height of our ball 1, we have gt squared over 2 equals to 32.2 times 2 squared over 2. And that shall lead us with our height 1 being equal to 64.4 feet. So, moving forward to our example number 5. A ball is thrown vertically upward with an initial velocity of 3 meters per second from the top of a tall building. The ball strikes the ground 4 seconds later. So we are tasked now to determine the highest point above the building reached by the ball. So pinakamataas. Determine the height of the building above the ground. So yung height ng building. And then determine the velocity of the ball as it hits the ground. So yung velocity na tinatravel ng ball bago siya tumama dun sa lupa. Now, example number 7, we use this equation. Our v squared equal to VO squared minus 2GH. Now, since our final velocity here would be equal to 0, we just use our initial velocity squared minus our 2 gravity and our height. So we transpose our negative 2GH to the left side, which turns our equation to our initial velocity squared minus 2 gravity multiplied by gravity and by height. So now, since we are just computing for the height, we divide both sides by 2g or 2 times gravity, and now we have h1 or our first height equal to our initial velocity divided by our 2 multiplied by gravity. So now we just input our values into the equation, and we have h1 equals to our initial velocity, which is 3 squared over 2 multiplied by g or our gravity. So we have h1 being equal to 0.46 meters. Then moving forward in the equation, we have v equals to v or our final velocity equal to our initial velocity minus our gravity and then our first time. Now we just our final velocity, which is not shown, so it's equal to 0, and then we transpose our gt to the left side, turning it positive. So now we have 0 equals to 3, which is our initial velocity, minus our gravity, which is 9.81, and then it's the 1. So now to find our first time, then we just move our 9.81 multiplied by t1 to the left side, so turning its negative sign into positive. And then just to segregate our time or our first time, we just divide it by 9.81, leaving us with a solution of t1 equals to 3 over 9.81. And then our first time would be equal to 0.31 second. Then let's move on into our t2 or the second time of our ball. So now we have t equals to t1, which is what we solved earlier, plus t2 or the second time. So we just substitute our values. Would be our time. As we explained before the ball hit the ground, it is 4 seconds, equal to our first time that we have computed, which is 0.31, plus our t2, which is what we're going to look for. So to do this, we just transpose 0.31 to the left side, leading us with the equation t2 equals to 4 minus 0.31, and then our t2 being equal to 3.36 seconds. So now that we have the our time, let's move on into the equation. So our h1 or our height 1 is equal to 0.46, and then our t2, which is equal to 3.69 seconds. So now we're looking for our height t. ht equals to vo or our initial velocity multiplied by time plus our gravity times squared over 2. Since our final initial velocity is not stated here, it is equal to 0. So our height total equal to gt squared over 2, which is now equal to if we put on our values, we have our height total equal to 9.81 multiplied by 3.69 squared over 2, since those are values for gravity and our height, our time. And that would lead us to the total height of the building being 66.79 meters. And then our h total, which lead us to ht equals h plus height 1, or the height in which we throw the ball upwards. So that would lead us to h equals ht minus h1, since we are looking for our h, and we just simply transpose our h1 to the left side. So our h would equal to our 66.679, which is what we just computed, minus the height we computed earlier, or our height 1, which is 0.46, leaving us with the height, the total height would be equal to 66.33 meters. And now we are looking for its velocity. Now we have v squared, or final velocity squared, equals to its initial velocity squared plus 2 multiplied by gravity multiplied by height. So now we're looking for, since our initial velocity here is 0, then we have v squared equal to our initial velocity equal to 0 plus 2g. So it's v equals to square root, since our v is squared, v equal to square root of 2gh total. So now we just substitute our value, and that shall leave us with v equal to the square root of 2 multiply our gravity, which is 9.81, multiplied by our height t, or ht, which is 66.79, leading us with a velocity 36.2 meter per second. And that's all for that example.
So, for the last lesson of this subject, we have the flights of projectile. So, for the example for projectile, we have a stone is thrown from a hill at an angle of 60 degrees with the horizontal at an initial velocity of 30 meters per second. So, after hitting level ground at the base of the hill, the stone has covered a horizontal distance of 150 meters. How high is the hill? So, for this example, we will use the Formula 1 and Formula 3. So, first, we will use Formula 1 to identify the time, or the given time, that the ball will land in the hill or below the hill. So, first, the formula is x is equals to v cosine theta multiplied by time. Since we have the x, which is 150, and the initial velocity of 30 degrees, or 30 meters per second, we will multiply to cosine theta, which is our angle is 60 degrees multiplied by time. Since we will isolate time to get the time, so t is equals to 150 over 30 multiplied by cosine 60 degrees. So our time is equivalent to 10 seconds. So after that, we will use the Formula 3 to identify the distance, or the height, or how high the hill is. So we will use the formula y is equals to v sine theta multiplied by t minus 1/2 g t squared. So h is equals to y, which is also equals to 30 multiplied by sine 60 degrees multiplied by 10, which is our time, minus 1/2 multiplied to g, which is our gravitational, which is 9.81 multiplied by 10 squared. So h is equals to y is equals to negative 230.69 meters. Since wala namang negative distance, ang representation lang ng negative dito is yung pababa. Meaning, makikita natin na pababa yung hill, which is also equivalent sa h is equals to 230.69 meters.